of course, number one is the results of the TIE trial, so-called TIE trial, or RV144, that was announced at the Paris meeting in October and published in the New England Journal in December. That result showed, for the very first time, after 27 years since the virus was first described back in '83, that it was possible to develop a vaccine that would confer protection, albeit modest and temporary, against HIV acquisition. And that result is something that is constituted a proof of concept, if you will, that it will be possible to make a vaccine. So the vaccine that was used in Thailand is not good enough to be a product. 30% protection for 1 year is not a product. But as a scientific result, as a scientific advance, it's huge. And it has energized the field, it has energized the funders, it has really focused the mind of how do we build on the Thai result? What do we need to learn from that, and where do we go from here?
People think that pediatric HIV is sort of a solved problem, and obviously the prevention of mother-to-child transmission has been arguably one of the most greatest successes we've had in HIV, but we still have 1,000 children getting infected every day in the world, and we have quite a few HIV-infected children in this country. We have about 100 to 200 newly infected children, and we also have a lot of teenagers becoming infected. For the kids who got infected, and for children generally, I have to say that antiretrovirals have just saved their lives. And so when we talk about the complications of HIV and its therapies, I think that particularly for HIV-infected children, it's been life-saving. Children progress to AIDS much faster than adults do, which is why now we know that we have to treat children as soon as possible, and the recommendations are within the first year of life, because otherwise they die. And as someone who had to take care of dying children, I think antiretrovirals are great compared to the alternative.
Most vaccines work, or at least depend very heavily on antibodies, which are proteins that you find in the blood, and they stick onto viruses and clear them. And so we're very interested in antibodies against HIV because that's what we'd like to induce in people through vaccines. But with HIV, there's a huge problem. And that is its massive variability. It's so different. Every virus is different. And so every antibody has to be, the antibodies that you induce have to be able to recognize all these different viruses. And that's quite hard to do. It's very different from something like polio, where you induce one sort of an antibody and it'll protect everyone, basically. So these sorts of antibodies are difficult to get, and over the years we've gotten a few of them, but in recent last year using new technologies, we managed to isolate, to get two new ones that were much more potent than the ones we'd had before, and other laboratories have since started to find more. So we feel we're on a real upswing here, that we're starting to learn a lot more and find more of these sorts of antibodies.
That happened in the AIDS community in 1983. People got together. We are not victims. We want a part in every, a part in research, drug approval, access issues, health care, nothing about us without us. There were newsletters that informed people about drugs, that allowed people to take this written information to their docs to say, hey, what about this? Why am I not a candidate for that? Why can't you get me this drug?
What's unique about our study is that we were able to actually link transmissions between the HIV positive and HIV negative person through viral sequencing of the virus in the HIV infected partner, the one that was infected at enrollment, and the person who's seroconverted. So we found 102 linked infections in the study. Actually, sorry, my apologies, 103 linked infections during the study. 102 of those happened before the person had initiated therapy, and we saw only one infection when the HIV infected partner had started on therapy.
We are really at a very critical crossroads with the HIV epidemic in the United States. As you know, there are more than 1.1 million Americans living with HIV, and nearly 1 in 5, or about 20%, of those HIV infected individuals do not know that they're HIV infected. So we have quite a bit of work to do to continue to raise the profile of HIV prevention, to encourage individuals to test, and of course ensuring that people who are testing are aware of their status and are able to be linked to effective treatment and care.
So let me start out by saying HIV-TB is an epidemic within itself, and many people are not aware that TB is the leading cause of death in the HIV epidemic. And it's estimated that last year 1.4 million people with HIV had tuberculosis, and that accounts for 15% of all the TB cases, but the 500,000 deaths account for 1/3 of all the deaths related to TB. So clearly it's a major problem. And as we know, HIV is a driver of the MDR-XDR TB epidemic.
Before we go further, can you
Sure.
explain what that is for our audience?
Sure. Multi-drug resistant TB is tuberculosis that is resistant to the 2 first-line drugs, isoniazid and rifampin. Unfortunately, we all know when we put selective pressure on organisms, we generate drug resistance. We have seen over the last particularly decade the emergence of tuberculosis that's even more resistant than the multi-drug resistant tuberculosis, which has been called extensively drug resistant tuberculosis.
So I first became interested in this topic really when I was in the middle of my training, and as a cardiology fellow I noticed that there were a lot of younger HIV infected gentlemen presenting with heart attacks, and at the time there wasn't that much study on this topic, so I wondered, is it from the effect of HIV infection itself, is it from antiretroviral therapy, or is it from traditional risk factors that cardiologists think about, things like diabetes or hypertension, and at that time there's really not that much known. So that's how I got interested in this topic. And I think there's been an increasing number of studies, both from our research group as well as others, that really show that HIV infection itself, independent of antiretroviral therapy, is a strong independent risk factor for cardiovascular disease.
And we found 2 pieces of information related to bone. The first one is tenofovir FTC or Truvada was worse on bone than Epsicom. And what I mean by worse is by doing a DEXA scan and looking at bone density, bone mineral density dropped after treatment to a much higher extent with Truvada than with Epsicom. Also, that was a little surprising, is that the protease inhibitor Reataz was worse than Sastiva. So bone density dropped to a greater extent with Reataz versus Sastiva.
But we're using them to keep people alive. The point of this idea is that when you're on antiretroviral drugs, your viral load, the amount of virus in your body, drops by about 10,000 times. It makes you much less likely to infect anybody else. So the question is, the drugs have an enormous individual benefit, but if we can also use them to stop transmission, then they have a great public health benefit as well. So the idea is we have to get people very early, put them straight onto antiretroviral therapy. And if we do that, there's no reason why we shouldn't stop transmission and eventually stop the epidemic.